Mm.
as we want to further learn more about 90%,
Yep.
what are there, whether they're structured or informal options as it relates to that, even if you meet some of that
Yep.
So yeah, I guess after the boot camp, we want to develop.
Yep. Right. So a good question. I think the best way to address that, this is actually a foremost question. Jeff long identified since I first walked the streets of Coogee Bay in Sydney. Jeff first identified the the inter-event community cohesion as sort of a key element of success of these sort of events. They're best not viewed as isolated, fragmented events, but as things that are knit into a process of community building and community ongoing communication and coming together. We have a number of resources that have been built up since I first tread the shores of that new continent, which are meant to support the community at different levels, and in fact, resources more broadly than we've provided for further education, et cetera. I think I'll try to address that tomorrow, late in the day. We have a bunch of slides related to kind of wrap up and next steps and that sort of stuff. So I'd value folding it into that time in the interest of having a coherent recorded discussion all together on that topic. Is that okay? Okay, great. Other questions or discussion that we could have right now? Yes, Kenny. Yes. Right. So I think so. There was a competition for what was called the Rachistochrone problem, I think, in 17th century. I was solving a mathematical variational calculus problem, and Newton submitted, as was common at the time for mathematicians, he submitted an entry, but it was anonymous. But Bernoulli looked at it and said, one recognizes the lion by his claw. And the point is that whether it came to Newton and the mathematics involved, or it comes to models, there's often a sort of signature with models or a way of doing things, whether good or bad, that sort of that is suggestive of a certain modeler. Sometimes it comes down to naming, sometimes to placement, coloring of items, visual effects, the particular abstractions used, the preference for like state charts versus events, how much is in code or how much is in a kind of built-in AnyLogic object. A lot of that is what I'd say at the implementation level. So I distinguish between sort of model conceptualization and model mapping, model conceptualization, model mapping, model formulation. But But even within formulation, I like to distinguish between two different elements. One is between sort of model design and then model implementation. So even within this stage, there's kind of what you want to build conceptually, and then there's how you happen to capture that logic, like whether you use an event or a state chart with an internal transition or something like that. That's a somewhat arbitrary thing, or I wouldn't say arbitrary. It's not that it has no implications, but both are responsive to what you want to build. They just capture it in different ways. So there are some differences in model implementation that are not so much about the scope and the sort of what we're capturing and what's part of the model as sort of how it happens to be captured. And certain modelers just have a penchant for doing things a certain way, and I'm not alone, in that category. I'm certainly would include myself in my category. So I think if many of my students saw a model created by me, they'd probably recognize, there it is. Maybe because it looks really ugly visually or something like that. But others put a lot of emphasis in the implementation into layout and to grouping things. And even I have certain, like I'll never draw a state chart going upwards, predominantly upwards. It'll always be coming down, and then sometimes it'll be going left to right for things. And same thing with like a system dynamics modeling diagram. There's just kind of normal conventions on how things are done, and modelers normally accord with those. Those aren't terribly deep, but they help accord with consistent conventions that aid communication modeler to modeler, and sometimes aid presentation, like others in the So I'm a big believer in building models for teams, not just for the modeler to get an answer, but to empower teams of people who look at it. An example is Wade's model that he talked about the first day, where his inner team sort of includes Cheryl and Laurie Bradford and Lolita. And I don't think Lolita or Laurie Bradford had ever seen this sort of modeling before, a year ago or what have you. And yet, as being part of a model team, you want them to be able to read the model and look at it. And if you're consistent with how you lay things out and so on, you gain benefit because they come to understand, okay, yeah, that's the standard representation for this, and they can just read it more easily. Now, there are some deeper differences when it comes to model design that often reflect the earlier stages, conceptualization and mapping. And there are big differences between different modeling impulses. So you'll find some people who tend to go deeper, some people who tend to stay prefer to stay a lot less articulated. You'll find some people are much more comfortable with certain types of sort of ways of formulating things. They'll reuse the same basic way of characterizing stages of change or what have you for behavior change, etc. And so, yeah, if you work with a given modeler, often you're dealing with sort of similar impulses for things. I think there's some variety, but if you go to a different modeler, you often find a different impulse. And for younger modelers, it's especially notable because it's important that they develop a sense of what's going to be fruitful for a project and what's going to cause trouble, given the stakeholders around it. Because it's not just a question of the model in isolation. It's the support environment it has and its level of comprehension to the stakeholders, the degree to which those stakeholders can work with it, and the availability of data. And in that whole morass, it's not obvious always what the right approach is, but you'll get different different impulses. One of the best things I find to do to address this is to have several modelers discuss it and compare notes. We've been running, I've mentioned it before, but I'll mention it again because I think it's an extremely effective and efficient mechanism. We run these hackathons where we have different teams doing things, and the students differ from each other in how they do things. A model created by Windchill, for example, looks quite different than a model created by my other student, Kurt Kruger. Kurt recently graduated from his PhD. Windchill is still in it, but in some ways is more senior to Kurt. But they sort of will arrive at somewhat different models and have them work on the same basic problem for a short period of time, like 3 days, 5 days, come up with different models and then compare the models is really actually very fruitful because it exposes the issues. Sometimes it exposes dead ends, often exposes opportunities, and often you end up taking pieces of different models and combining them, or you synthesize them in some way that responds to the strengths of those models. Now, I recognize that most people don't have the luxury of doing that, but where it is possible, it's very effective. I would say one thing that is very good, if you're only working with one modeler, maybe that's someone with whom you have a close collegial relationship, or someone who's on this longer-term grant with you, and you're going to be working with them. One thing that's useful to do is to talk some with the other elements of the modeling community to ask sort of, are there certain aspects of modeling that where this person is particularly strong, or where they have where they may need some growth, or where additional opinions may be needed in order to help yourself from getting too heavily pushed just from their side. Another thing is, if you're working with a senior modeler, you might work with students of them at different times, and there's often an interplay of different visions because there's the senior modeler's understanding, and then the student's approach to it may be different in perfectly reasonable ways, and so you get, again, a plurality of different views. The other thing I will say is, even if you're not the model yourself, and most of the people in the room, I don't expect to necessarily go and become the key modeler for a model, but it'll behoove you to take a look at many models and to say, hey, to your modeler, hey, I looked at this. What do you think of this? Look at what they're doing. And encourage the modeler to look at the literature too and look at the diversity of models. One of the problems of modeling as a community is, and I've seen this in spades, is that different segments in the modeling community tend to be quite inward-looking, quite sort of focused internally. This is particularly strong with the system dynamics community, which is almost insular in some ways. Although I and others have taken efforts to break that down, and with the newer generations, there are reasons for some hope with that. But even the ABM community, traditionally the ABM community doesn't pay attention to what the SD community does, other than to kind of criticize it, and vice versa. And they're like ships in the night passing each other traditionally. And it's a silly thing because they have more commonalities than differences. They're both dynamic modeling traditions that are both motivated by the same underlying thoughts. They have somewhat different processes, but fundamentally to deliver value along similar pathways, and some of the goals of the models are overlapped. Now, some are different, and that leads to that's one of the big reasons. This is something else you got to watch out for with a modeler. This is a big difference that is often unwritten. In a way, it reminds me of the encounters of world religions in the 19th century, particularly, where different world religions met up, and often their attitudes with respect to one another were very critical. But at a certain deeper level, it reflected a lack. They often interpreted the other religion in the terms of the questions they were asking, whereas often what they weren't seeing is what are the deeper questions being asked by these different lines of thinking and approach to religion. And so it is with models. A lot of the acrimony between the communities, or the traditional tensions, I think reflects the fact that each community views the other as trying to address their own questions and misreads it because the other community is trying to address predominantly different questions. System dynamics community has a really strong emphasis on changing mental models. The ABM community traditionally has not understood that and not appreciated that. Their focus is on, capturing essential behaviors from agent-agent, agent-environment, agent interactions, and capturing the essential features of the situation. The microsim community is all about, capturing statistically valid patterns associated with historical data and projecting it forward. And each of them looks at the other and sees it in their own image, in interpretation of their own questions, and ends up critiquing it from that perspective. But that's missing the point. They're addressing different questions, and therefore the tools they use tend to be different. And this is part of the reason they're so inwardly turned, because they don't see as much value in the other communities. But a lot of the time it's because of blinders. So you want to look for modelers that you work with that at least are open-minded about other techniques and help alert them to other techniques of relevance. You also need to look for modelers who are open to your sort of questions. Because if you work with a modeler who is interested, only in prediction, their notion of a successful model is a model that accurately predicts, and you're seeking to use a model for theory building, you're going to be sorely disappointed typically, because they're going to be trying to push one way and you're pushing another way, and they'll see a success you'll see as a failure, and vice versa, et cetera. And there's going to be a tension there. And so at the least you need to help them understand your goals and make sure it's compatible with their interests. Because I've also heard some modelers say, like in the health arena, I've heard modelers complain to me. They say, I talk with these public health policymakers and they ask me boring questions. And I don't want to work on those questions because they're boring. And so I want to work on interesting questions, like questions where I can prove theorems about it and so on. And they keep on bothering with boring questions, and it's a pain. So I don't know if I want to work with them much. So you don't want a modeler like that, who just wants to answer their questions because of their disciplinary prejudices. They think they're privileged questions and the others are less worthy of their attention. Just be aware not all modelers are the same. Now, I'll further tell you this. This is one of the biggest, most important things to know, and it doesn't fit neatly in any boot camp exercise, so I'll just mention it. I know we all look like geeks, okay? And I am a geek, and proudly so. I used to have a nerd pride button until I gave it to another nerd. And that's all fine, but not all geeks are made the same. And it's not just the difference in handedness. The difference, if you look at me, if you look at a modeler as predominantly someone who just needs computer skill, you'll be setting yourself up for a big challenge, okay? Because there are folks I know who, when they go to hire a modeler, their primary qualification is, I want to hire someone who knows Java. And they assume that someone who knows Java, they can come in and create their model, because after all, they know how to program, and they'll create this model for them. The problem is, most people who know Java, first of all, aren't necessarily even software engineers, so they may create really bad models in terms of implementing the model wrongly. But the worse yet, they won't have any clue about what model to build, because most people who are trained in programming don't have the training to characterize systems at a process level. It's not part of the normal undergrad curriculum. And so there's a fair number of people who go off the rails because they say, okay, we're going to build a model of X. The first step is hiring a programmer. So we're going to hire this programmer because programming is important to building a model. And then they assume the programmer will build them a good model, and it's just wildly off. I mean, it's just whacked out, in what comes of it. Because at best, the person turns it into a fun little programming amusement, or into a software engineering thing, and they end up with something that's not basically a useful model. So you have to realize, just as it took me 20 years ago, to kind of parse out the different type of health scientists, and like clinicians have different interests than epidemiologists, and stuff like that. It takes years to kind of recognize that the geeks have differences, and there's kind of a software engineering geek, and then there's like a security geek, and then there's like a system administration geek, and there's like a distributed computing geek, and not all these geeks are suitable for working for your goals. You want the right type of modeler for your needs, and you want a modeler who has a good reputation in delivering those sort of needs, or at least has a very open mind, even if they're not highly experienced. I don't know if those comments are helpful. Those are important principles that sometimes don't get said. Yeah. Any other questions, just while we're at it? Yes. Yep. Mm-hmm. Mm-hmm. Correct. Yeah. Well, I was going to say, I thought you might be taken another way, because there's a cult of youth in some areas of the tech industry. In Silicon Valley, it's almost a cult of, the younger you are, the kind of more with it you are, something like that, right? You've seen it too. And the truth is that youth is not a recommendation for doing modeling. Actually, it really helps to have a certain requisite level of exposure and experience, and have seen enough things that you're going to be able to avoid a lot of common problems. Now, I will say that to be actually a really high-quality software engineer, it also helps to have some time to develop best practices, have some time to be functioning around really high functioning teams versus teams that are having trouble. It gives you a certain savviness. A grizzled professor at MIT once told me, he said, Nate, as you grow older, you don't get any smarter, but you get a bit more sly. And the point is, you get a bit. You're able to recognize this sort of, oh man, it's that problem again. Oh, he's heading down that road to make that mistake. Believe me, I in my time have seen a lot of it. Jeff has seen even more, I think, of it. And there's just certain characteristic failure modes, certain characteristic classic things going off the rails in certain classic ways that that you see again and again. And I think age is not a higher age is certainly not a disqualifier, and I actually think some experience and quite a bit of experience modeling things is really useful. And this is one of the reasons why I asked my TAs to be here. Where are they? Where are they? Thank you for those who are here. It's appreciated. But No, I asked my TAs to participate in these boot camps. I asked my TAs to participate in hackathons because the more you go through it, it really adds to your repertoire. And it challenges sometimes how you would do it with how other people do it, and hopefully you learn to avoid certain mistakes and get others. So I would say too young, it can be really an issue. I mean, Jeff and I have had to deal with the challenges of callow youth. I won't even go there. Don't get me started with it. But yeah, Jeff and I have had several challenging experiences, many of them concentrated in those who are as yet with the blush of youth. They come in different shapes and sizes. Sometimes it's attitudinal. Sometimes it's overconfidence in their impulses. Sometimes it's just cherished prejudices of approaching it one way because they're not aware of other traditions. But still being in the earliest years of your career is not a recommendation for being a savvy modeler. That being said, there are some new people, young people that I know that are very, very promising. But over time, they will grow in experience and hopefully wisdom in a way that will lead them to contribute at a more deep level to modeling. Also, by the time I'm my age or Jeff is his, and you've been doing this for decades, you actually start to see models of the same area many, many, many times. And so you have more and more points of reference, more and more knowledge, and critically, and this gets to my point to Kenny, you start to look beyond one tradition. Like you look beyond the system dynamics area, and you start to see publications, agent-based modeling. You start to find publications from microsimulation, all these different areas. The problem is you're not going to find them really easily if you just search for system dynamics modeling. You're not going to find them. Or even if you search for agent-based modeling, you're not going to find things that would qualify just because they happen to call it individual-based modeling, or they called it a mechanistic model and happens to be based around agents. So this is part of the challenge is appreciating the literature, and you get more exposure to that with age if you are circulating outside your community. But there are, older individuals who are just as partisan to their community as any, as Jeff can attest. Yes. Okay, so those are some comments. Any final comments? This gives us, okay, thank you very much. I welcome these questions and